Hello, friends. Welcome back. So, myself, Sanjay Kumar Adhikari, and today I am going to discuss this ESP8266 Wi-Fi module, and this is based on request from some of the students who wanted me to start something different from regular C, Linux, and at Mega related stuff. So here no programming knowledge is required to complete the steps here, and this setup is okay for basic communication with default program in ESP01 module. If you are planning to change the default ESP01 program or firmware, you need to use ESP01 kit. So on the left side, this kit comes with both programming options. So there may be like option to use the breadboard for that, but you may have difficulty sometime due to loose connection and those kind of stuff. That's why I don't recommend that. And if you are using mobile to view this, so on the top right side, in front of Embedkari, you will see that horizontal bars 3. Just click on that, then on the left side scroll down, you will see these things. Just you click there, it will take you to that Amazon site. Okay, please subscribe to YouTube channel Embedkari, and for further discussion on embedded systems, I recommend to use laptop or PC with headphone or at least tablet for watching related YouTube video. And what is the key takeaway for students, whether they are just at school level or starting this basic IoT node? So this will be basically can be first Wi-Fi project with 80 commands. So 80 commands basically used in GSM phone or modem. Okay, so this is simply application level command which can be passed through to the device through serial communication. Okay, so generally ESP01 comes with default ESP826680 firmware, which has complete TCP/IP stack and also things like DHCP and all those things. So first step, I used this ESP01 Wi-Fi module with 3.3 volt DC 2 ampere power adapter. So this is not necessarily exactly 2 ampere, but whatever I used I am sharing here. So I use simply one mobile charger for this purpose, and I wanted to use that separate supply for this module, and also use this APTD 1232. This is the USB to TTL. It has both the option 5 volt and 3.3 volt. So since our device will be ESP8266 will be working 3.3 volt, so it has to be used at 3.3 volt. Okay, and 3.3 volt as on below. So in this diagram, so here you can see the VCC and the CHPD connections are being taken 3.3 from the DC adapter, and another command RX pin is RX connection is going here, and then RX TX will be TX to RX, RX to TX kind of stuff, and ground should be common for both. Okay, so there is another connection that is ground GPIO 0 connection. So that is normally not used, only it has to be used for refreshing the program, and that there is one RST pin here. So RST pin basically can be used for resetting that program. I will show you below that how it is being used, and resetting the module, basically reset pin. One important thing is in this particular module, whatever the diagram basically shown here, in this diagram it is showing this is for depends on the module to module what jumper, what manufacturer, that module manufacturer has done. So in my particular module, I can see this 3.3 board is on the left side. So this way I have set it. I have basically marked it here. You can see this. Okay. So make sure that you have 3.3 board option here, and for communication. Okay. Otherwise it may damage that port. This Wi-Fi module port. So in overall, my setup is looks this. This is basically our TTL to USB USB like interface, and this is going to the laptop. And you can see this ground pin is connected to the ground here, and ground and power supply coming from the external mobile charger 3.3 volt. This only ground is going here. The power supply anyway will come from 5 board will come from the laptop. And here basically you can see these are the two wires, TX and RX only required here. So both are connected through this cable to this ESP8266 model. And this is that 1K through 1K resistance, this provision to sort this RST pin, visible here, second number, so that sometime to reset the module. This 1K I have taken this resistance so that it should not damage the GPIO. So all the precautions has to be taken care so that you don't damage your module. Okay. So once you power on this, after you are sure that okay, this correct power 3.3 board jumper is set, everything is okay. So you can power first your this microcontroller, then through that that power supply, then your through the USB you can connect to the COM port. So that COM port, as we have seen in case of Arduino Uno board, so the method is same. In the Windows 10 machine I have to enable this. So this hidden devices from the device manager, and if from the command you have to go to the device manager and see the port, and in the port it will be whatever is that once you connect that port enabled will be highlighted. Here you can say others seems to be not enabled, not connected. So this one is COM3. So my port, once I know that my port is working, so what I have to do, I have to select I have one application, and so this I can show you here. This particular RealTerm I am using. Why I am using, you will realize that this port is 115200 port 3. So open. So if you have to change this port for some reason, you need to close it first, then change this whatever you type here and change, then you open it. Okay. So and again, then for sending the data, you go here. Okay. So what happens, like suppose if it is not working in the beginning, so what we need to do, I'll go through step by step here. Okay, so this the same thing it is explaining here. So let me show you that what I need to do. Normally it should, from if I type AT command here, then I can send this, it will respond okay, it means it's fine. If suppose if you are to type that command here itself, so what you can do, AT here, but you make sure that nothing is on this particular place on left side on send number, then send ASCII, then okay. So right now it is working fine, but suppose if it is not working, then what you need to do? Suppose it is status like this, then what you need to do, you need to take your that cable, that is that RST ground cable, this cable, and touch to this RST momently, and you will see that some blue light there, then it will, at the same time you will notice that if I clear it again and I will do it right now. So now you can see the complete, it is booting. Okay, so like already booted, so you will see that message there, proper message here. And after that, if you give that AT command here or on the top, so send ASCII, so it will say okay, it means communication is established, has been established. Now make sure here in this, that's why I have chosen the RealTerm, because with the command we have to send these two things, carries return and line feed. So I checked, otherwise it will not work. Okay, so let's see what other things being discussed here, so that we will do the same practical. And same thing, type AT command, and this I have covered. And touch ground wire to RST. So this is basically I have given here how it works in the blog also. And now at the end, basically for this particular session, just I wanted a getting start kind of thing with this module, and later we can see what more we can do with this particular module. So today let's see some commands I will try here. One by one we will try. Let's say if I clear it, I will try only two commands here. So rest of the command you can try at your end. So AT plus RST, that is the reset. Okay, if you send this, so module will reset from here also. Right now you can see the proper message, because you are doing some sort of soft reset here, not the power on reset. So that's why you are able to see these messages, SPA speed, SPA mode, SPA flash related, then it is jumping to that application, and then it is showing this RTC data and all that. So another command, basically if you want to see that version and all that kind of, that what version this module, send number, it should be send ASCII. So you will see that top, what it is showing after GMR, you can see that top, it is showing that AT version, whatever the firmware version 0.40 whatever, and date, and then SDK, software development kit, where this particular firmware was developed, that version. And below that you can see that build version, means when it was compiled, that detail you will find that. So others basically give the local IP address and all those kind of wireless local access points, so that I am not doing right now here. So you may try that yourself for your setup. So this is and this is related to ESP01 module, and that this gives basically good exposure to someone, even that school students, some sort of this experience with this command, that how the device respond. If you and the same commands can be used with GSM module. Basically this is the standard. If you go to look into the wiki, you will find that this is the standard for GSM. So that give the exposure to use these commands with the Wi-Fi module. You can set IP address, you can set it as a server, Okay, so lot of possibilities are there, and right now I'm giving all these commands through that PC laptop. So later, what you can do only that this only TXRX pins we are using. So you can add ground pin. You can connect interface that another microcontroller, let's say Arduino or something like that, where you can drop down that voltage to that 5 from 5 to 3 for IO port voltage, so that it matches this one, and then uh, that can communicate directly with this module, and this module also having two GPIO pins. Okay, those can be used, and I will be discussing the detail about this module and that processor in the next session. Okay, and thanks for your time, and if you face any problem, any issue with that whatever I have explained, please drop a command so that I can improve it in my next session, and drop a comment, sorry, and please subscribe to YouTube channel Embedkari as well for additional embedded related stuff. Okay, thanks for your time. Have a great day.